video lesson is on adding fractions. And I'm really excited about adding fractions because I get asked all the time, when am I ever going to use this? Okay, common math question, I understand. Sometimes you do things that you don't see the relevance in real life. Well, adding fractions, I have two great examples of when you might use them in real life. So let's look at the first one. Sam and Gavin, just read along with me as I read aloud. Sam and Gavin have a competition each year to see who can eat the most pie. This year, Sam ate 2/3 of an apple pie, and Gavin ate 4/5 of a cherry pie. Find out who ate the most pie and how much they ate altogether. So, I've given you two circles here to represent pie, and Sam ate 2/3 and Gavin had 4/5. So I'm going to, those of you who are visual learners, I'm going to visually represent those two fractions of pie. So 2/3 of pie, I'm going to break this into thirds, and a peace sign is a real easy way to break it into thirds. And he ate 2 of the thirds, so 1 and then 2. And Gavin ate 4/5 of his pie. So fifths is a little bit harder to make. We can do 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. I'll give you a second if you're not as experienced as breaking into fifths as I am, but go ahead and break your second circle there into fifths. And so 4/5, I'm going to go ahead and shade in the 4 pieces to represent the 4/5 that he ate. So visually we can see here, who ate more? Sorry, Sam, but Gavin ate more, okay? 4/5 is a larger fraction than 2/3. So 4/5, so Gavin, that's our first blank, Gavin ate more pie because 4/5 is greater than 2/3. Okay, now the second part of this question is, how much did they eat all together? Well, there's where adding fractions come into play. So we're going to add these two fractions. Well, adding these two fractions, this is an apple pie, okay? So an apple pie, this is a cherry pie. Apple plus cherry doesn't equal apple, and it doesn't equal cherry. An apple plus a cherry, we're going to have to say it equals fruit, okay? So when we add fractions, it's like saying an apple plus a cherry. Well, an apple plus a cherry doesn't equal 2 cherries. It doesn't equal 2 apples. It equals 2 pieces of fruit. So we have to find that common thing that those two fractional pieces have. So the common thing that these two fractions have is going to be some multiple of 3 or 5. 3 and 5, a multiple. You have to multiply to get that number. So let's list out our multiples of 3. 3, 6, 9, 10, 12. That's not true. Now I just started counting. 12, 15, 18, and so on. So those are some multiples of 3, because 3 times 1 is 3, 3 times 2, 3 times 3, 3 times 4. What about multiples of 5? Stop me when I have a common one. 5, 10, 15. Hopefully you yelled at your screen, stop! Because 15 and 15 are common, and that's what we want to find, a common denominator. So 15 is our common denominator, which is a multiple of both 3 and 5. I can multiply 3 by something to get 15. I can multiply 5 by something to get 15. So I'm actually going to change the amount of pieces I have of pie. I'm not changing the amount that they ate, but I'm changing the amount of pie. So watch how I do that. If I want my common denominator to be 15, I have to ask myself, well, 3 times what gives me 15? And I know that that's 5. Well, I need to multiply by 5 over 5, because 5/5 is the same thing as 1, and multiplying by 1 doesn't change the value. If I multiply by just 5, I'd increase my amount, but I only want to keep it the same, just look different. So now I have 15ths. And I can visually represent that because each third I multiply by 5. So each third I'm going to cut into 5 pieces. So there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have 15 pieces of pie, but he didn't eat 2 of them. He now ate 10 of the 15ths, because that's the same thing as eating 2 of the thirds. So I can see that by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so he still ate that much of the pie because 5/15 is left. So he still ate the same amount of pie. We're just comparing it in 15ths. So now Gavin, 5 to get to 15, I have to multiply by 3 over 3, and so I get 12/15. So each fifth is going to be broken into 3 more pieces. So I'm going to make 2 more slices on each fifth of a pie. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so he still ate the same amount of pie, 4/5 of the pie, or 12/15. Same thing. Okay, so together, he ate 10/15 and he ate 12/15. So we can compare. We can add these because they're both broken into the same fractional pieces, 15ths. So 10/15 plus 12/15 gives me 22/15. So together they ate 22/15 of a pie. Well, that's not usually how you say that. That's an improper fraction. To change this into a mixed number, I'm going to divide 22 divided by 15. 15 goes in, or 22 can be broken into one group of 15. And then we subtract, we get 7. Okay? So then my remainder is 7. So I say that this is 1, my whole number, and 7/15, because we're still talking about 15ths. Our pie's still cut into 15 pieces. So 1 and 7/15 is what they ate together. So they ate 1 and 7/15. I gave you a real big blank for that little fraction of pie all together. Good. All right. So there's adding fractions, example number 1. Now example number 2. So sorry if you're hungry. This is going to make you want pie and cookies. So here, you are baking cookies and you need 2½ cups of flour. Hopefully you've baked cookies before. If not, you can try that sometime. Cookies are great. 2½ cups of flour in 1 bag of flour. So you have 2 bags of flour that you've kind of used but not completely used up. So in 1 bag of flour, you have 3/4 a cup. And in another bag, you have 9/7 of a cup. Do you have enough flour to make your cookies? So visually, once again, we're going to represent. Here's 1 bag that you found, and it's 3/4 full. So I'm going to break this. This is my bag, okay? So imagine it's a bag. And it's 3/4 full. So I'm going to show fourths, and then I'm going to fill it up with flour 3/4 of the way. Okay? So that bag's almost full. It has 3/4 cup of flour. Now these bags, 9/7 full of flour, 9/7 of a cup. So 9/7, I actually know that 9/7 is improper. So it's greater than 1. So 9 divided by 7, 9 can be broken into one group of 7 with 2 7s left over. So I'm going to shade the entire bag. Okay? So you have another bag. I guess there's 2 bags. So I didn't write the question perfectly, but you have 2 bags. So 1 bag and then 2 7s. So I'm going to break this into 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6, 7 pieces, and it is 2 of the 7th way full. So now I want to add 3/4 plus 1 and 2 7s. Okay, well, I can add this mixed number, and I can just keep the 1 there, and I can add the 3/4 and 2 7s, or I can add it to the improper fraction. So let's try both ways. So I'm going to try to divide by 9/7 first. 3/4 plus 9/7. Again, I need that common denominator. So I'm going to list out my factors of 4. I guess I have to keep going. This probably wasn't a very good example. May have to find a big common denominator. Oh, I can stop. Okay, so my factors of 7 then are 7, 14, 21, 28. Okay, so I can stop. And really, you could have just multiplied those together. And you can see that 28 is my common denominator. So if I want to slice this into 28ths, I need to make each fourth broken into 7 more cuts. So I'm going to multiply by 7 over 7. And I get 21/28. And then 9/7, in order to get 9/7 to 28, I'm going to multiply by 4/4. Okay, so then I get 36/28. So then I can add 21/28 with 36/28, and I get 57/28. So do I have enough flour? Well, I needed 2½ cups. Is 2½ greater than or less than 57/28? Well, let's go ahead and divide this out so that we can see if 57/28 is going to be enough. So 57, can that be broken into 28 times 2 would be 56. Okay, so it goes in twice with 1 left over. We could add a decimal, or we could say it was 2 and 1/28. 2 and 1/28 is my mixed number. So I have 2 and 1/28, and I needed 2½. Well, 1/28 is definitely smaller than 1½, so no. No cookies for tonight. I can't make my cookies. Okay? And how do I know? Because that's not a good way to start a sentence. I know because 2 and 1/28 is less than 2½. So I don't have enough. Alright, so let's go ahead and you're going to pause the video, and I want you to try to add these and then play the video to get your answer. So go ahead and pause the video. Alright, so 2/5 plus 3/8. Hopefully you found the common denominator of 40. And 2/5 times 8/8 is 16/40. And 3/8 times 5/5 is 15/40. And when I add them, I get 31/40. And that's already in simplest form. So if you got that answer, give yourself a star, do the next one, and then pause. Alright, so hopefully you found the common denominator of 36. And 1/9 times 4/4 is 4/36. 7/4 times 9/9 gives me 63/36. And when I add them, I get 67/36, which is improper. So you could change that to a mixed number if you wanted, or just leave it as 67/36. And then the last one, I have this mixed number here. Hopefully you know that when you're adding and you have a mixed number, add the fractions and then just keep that whole number. Just leave it alone for now. Okay? So let's add 2/7 plus 4/5. So a common denominator here would be 35. And I'm going to multiply by 5/5, and I get 10/35. And I'm going to multiply by 7/7 to get 28/35. When I add those, I get 38/35. Now that's improper. I want to make that a mixed number. Okay? So 38 can be broken into one group of 35ths. So one group, and I have 3/35 left over. Now I want to bring down this 6. And when I add those together, I just get 7 and 3/35. So that was a little bit of a challenging problem, but hopefully you got the right answer. Thank you so much for watching. I hope you have a good evening. See you tomorrow.